Alright, let's look at the Euler equation. Alright, Euler equation is written in this form. Ax squared y double prime plus bx y prime plus cy is equal to 0. Alright, there's a convenient substitution to turn this into a linear equation with constant coefficient. Alright, so let's look at that. Alright, so substitution is this. We're going to let v be natural log of x. Right? Then let's take the derivative of this and see what we get. So the derivative of v with respect to x would be dv over dx is equal to derivative of natural log of x is 1 over x. Alright, then let's look at the y prime. Alright, so what is y prime? So y prime is derivative of y with respect to x. Right? But we can rewrite it as, let's take the derivative of y with respect to v first, then multiply by derivative of v with respect to x. Right? So you see that this is actually equivalent to dy over dx, because you would be able to cancel dv on top and the dv on the bottom to get dy over dx. Right? Right? But dv over dx is actually here. So what we can do is we can plug this in here to rewrite the y prime as, right, so I'm going to write the dy 1 over x first. Then you have a dy over dv. Right? So that's one way to rewrite y prime. Right? So let's take another derivative. How about the y double prime? Right? So we already have a y prime, so what we need to do is we can just take the derivative of 1 over x dy over dv with respect to x. Right? Since this is a product of two things, right, we're going to have to use the product rule to take the derivative. Right? So the product, so the derivative is going to be derivative of 1 over x is negative 1 over x squared. So this is just a power rule. And times dy over dv. And plus, first leave the first guy alone, so 1 over x. Then take the derivative of dy over dv with respect to x. So again, I'm going to actually go ahead and take the derivative. So this is going to second derivative of y with respect to v first. Then multiply by dv over dx, just like the one before. Right? And again, we can put 1 over x in here, because you have another dv over dx. So what we get is actually we're going to get, let's see. Alright, so 1 over x squared here. There's another 1 over x squared there because it combined with 1 over x here. So I'm going to put the 1 over x squared pulled out. And I'm going to write the second derivative of y with respect to v first. Right? Then we're going to have, there's a negative sign minus, right, dy over dv, dy over dv, right? So this is another way of writing y double prime, right? So what we're going to do is we're going to plug those into the original equation. So the original differential equation is going to be, all right, so I'm going to go here, so this can be rewritten as, right, we're going to have, so you have a ax squared but y double prime is 1 over x squared times second derivative y with respect to v, right, minus first derivative y with respect to v, right? Then plus bx, and the y prime is 1 over x times dy over dv, and the rest is exactly the same. So you have a cy is equal to 0, right? Actually, I'm going to just move this guy down here. So I'll take this and I'm going to move it down here, right? And we're going to clean it up a bit. So you have here x squared and x squared cancel out. Here's a y, x and x cancel out. Alright, so I'm going to just collect like terms. So in this case, I'm going to just pick a times second derivative of y with respect to v. So you end up getting a times second derivative of y with respect to v. Alright, then the next one, you have dy over dv. So you have a here times negative dy over dv, and then you have a b times dy over dv. So if you combine that together, you're going to get b and minus a dy over dv. And then rest is plus cy is equal to 0. So that takes care of the remaining term. Alright, so you can see that you would have a constant coefficient. Right, so this one, you can see that here, this is a constant, and this is another constant coefficient. This is also constant coefficient. So these are all constant. Oh, actually, I can't spell constant coefficient. Right, so we can actually solve this using characteristic equation. All right, so let's look at an example here. All right, so we have this, and you can see that here our a is going to be equal to 4 there, and b is equal to 8, and c is equal to negative 3. Right? So using a substitution, so we're going to still let v is equal to natural log of x. Then you will get this new equation, right? So it's going to be a times, so it's going to be a, which is 4, times dy, so second derivative y with respect to v, right? Plus, right, this is going to be a b minus a, so it's going to be 8 minus a is 4, dy over dv, minus 3y equals 0, right? So we have a new equation which has a constant coefficient. So we can do a characteristic equation. So a characteristic equation would be 4 r squared. So 8 minus 4 is 4 r minus 3. Right, so this is equal to 0. Alright, so let's factor this guy out. We're going to get probably 2r and 2r. Alright, then we're going to have probably plus 3 here and a minus 1. Hopefully that would work. So it's a negative 2 plus 6, so it's going to work out. So it's equal to 0. All right, so this will give us two r values. So you have a r is equal to, from here, negative 3/2 power. And from here, we get the positive 1/2 power. All right, so this gives us the solution. The solution is going to be y is equal to c1 e to the negative 3/2, but this one is a little bit careful. This derivative is done with respect to v, so the variable in this case is v. All right, plus c2 e to the positive 1/2 v. All right, but since the original equation is given in x, so we have to write the solution in x as well. But we can just put the substitution back in. So therefore, we have a solution. Y is equal to c1 e to the negative 3/2 natural log of x. Right? V is originally natural log of x. And a c2 e to the 1/2 natural log of x. Right? Then what we can do is we can do a little bit of rewriting. Right? So here you have negative 3/2. We can place it up here as a power. And you have a 1/2 and place it as a power up here. Right? So you can see that you have e to the natural log cancel out. E to the natural log cancel out. So you end up getting c1 x to the negative 3/2 power plus c2 times x to the 1/2 power. All right, so this is the solution of the Euler equation here. All right, so key is, that's not good. Key is to use the substitution to turn the equation into an equation with constant coefficient. Then we're going to use the characteristic equation to find the solution, but this is in terms of v. Then we can put the substitution back in to write the solution in terms of x. All right, that's it. I hope that this was clear.